This video is just going to walk you through a little activity on Classpad.net. It's about using real facts about the moon and using images. So you'll see this activity, Moon Madness, exploring interesting things about the moon. And here's an image. So this is an image that's actually, if we click on it, it's been inserted in the geometry sticky, which means that you are going to be able to do geometric constructs on top of it, which is going to come into play later. So they're given a bit of information about the moon and the earth, the radius of the moon and the earth's radius in kilometers. And then the questions they're asked relate to those numbers. How could you use those numbers to answer some of these questions? So the first one is, to the nearest whole number, how many times bigger is the Earth compared to the moon? So this is involving students understanding that you could set up a ratio and figure out what's the ratio of Earth to moon and then round that up. So this is a calculate sticky. We could just enter our numbers here, Earth, and use our fraction button here, or division, or use division and do the same thing. Oops. 1737. And we're going to get a decimal answer. And what we are asking them is to the nearest whole numbers. So the Earth's about, if they were to round this, understanding their rounding rules, 3.6 is going to round to 4, so about 4 times bigger. So they're going to answer that question. It's about 4 times bigger. So then using that understanding, could you make a scale model using geometry? So here's a geometry sticky, and it wants them to use a scale model with just circles to represent the Earth and the moon, and start with the moon having a radius of 1 centimeter. So how are we going to do that? So they could get a circle tool and make a circle, and then use their measurement tool. So we're using geometry to help us, and we could measure the radius. One way we can do that is measure it, and here's the radius. And the neat thing about Classpad is once you have a measurement, you can actually then change it, and we want it to be 1, right? So here is a radius of 1, right? So there is the moon, and now can we do a circle that is 4 times larger and have that to be scale? And then we can talk about similarity and how you know that that's proportional, those types of things. So I'm not going to do all that, but that's where you would go with this. So that's question 2. They're going to actually just make their own scale model. So then, based on this, we figured out it's 4 times bigger, and we figured out that we could make our own scale model by making a circle that represents a moon and making a larger circle with a 4 times larger radius that's going to be 4 times the size of it. And that's a better scale. And so then it says, okay, go back to this picture, because the question they were asked is this image to scale. And so now they could actually do the same thing. Maybe we change the color here. This is in a geometry sticky, which means I can actually make a circle. I'm trying to see if this picture's to scale, and whatever this radius is, if I make the radius for this circle, if it's to scale, this radius should be 4 times larger than this radius, and is it? And then we can say yes, it is scale. So it's just kind of cool application of this. So that's where we're going. Then there's a second activity, and they're given the real diameter of this crater that's on the actual moon. So this is an image of the actual crater from the moon, and they have to figure out using ratio and similarity again, how much larger is the real crater? So if you were on the moon, how much larger is it than this image right here? So that is again a ratio proportion type of problem. And then down here is another type of problem. They're going to be kind of calculating when the moon, how far the moon is away from the Earth. And so they're giving some information, and there it is, and a function that describes it. So they're going to go down here and they're going to graph this function, and I'll just show you, and they have to limit it. So we want to look at the first 2 billion years, basically. I'm just going to copy and paste, make my life easy right now. And when I graph this, they're going to see the graph, and they were limiting the domain to the between 0 and 2000, and they have some questions. So what's this slope? What does it actually represent in connection to this problem? What is the y-intercept? What does that represent in connection to the context, and stuff like that? So this is just a different type of looking at moon data and Earth data and kind of making some comparisons by looking at a graph. and using some of our algebraic representations to explain the relationship. So have fun with this activity.